we have to start analyzing this house, and this house has walls. If we select on the wall and we go to edit type, the R value of this wall should be, this is 21. Oh, this is 21 because that's the garage. Okay, so here we don't need that thermal insulation, but when we have the wall in the living room, if we edit type, this R value should be 50 or close to 50 to meet the passive house standards. Okay, if we have the roof and we edit type, this value should be above 50, it's 66. Yeah, so everything between 50, 60, it's good enough when it comes to the passive house standards. And what about the floor? I created that floor generic, but if we edit type, that floor doesn't have any thermal resistance. Well, I don't like that, so I'm going to create a floor. So let's edit type. The structural element, it's gonna be concrete, because in floors we have always a concrete slab. So let's do this concrete cast in place. Okay, so this is 1 foot, 1 foot. Let's make it 8 inches, no, 8 inches. And I'm going to insert a new layer. Okay, so we have this structural layer. I insert this. I'm going to move it out of the core boundary, because the core boundary usually it's the structural element, so it's the concrete. So what we have above is thermal. We don't need a lot of thermal insulation here, so I'm going to select thermal insulation, rigid insulation. And this can be like 3 inches. And finally, I want to insert a new layer, and that's the finish. And I'm going to make it flooring. Do we have floor, oak flooring? Okay, oak. Let's do that. And the thickness, let's say 1 inch. Okay, so this thermal resistance is 14. Okay, if we edit type, the thermal resistance is 14. According to the passive house standard, should be between 20 and 30. So if this is between 20 and 30, what can we do? Maybe we can increase the thermal insulation 3.5 inches, and we can decrease the flooring probably 1 inch. Would be too expensive. And now the thermal resistance is 16. Okay, so we can make this the concrete 7 and the rigid insulation 4.5, and now we have 20. Okay. So everything that it's around 20, from 20 to 30 for floors, is good enough. Around 50 for walls, around 60 for roofs. We have, I think we have a good envelope. If we select windows, make sure that it's always low emissivity, triple glazing, and all that stuff. Okay. Okay. So once we have this, we need windows in every living space. Okay, so well, in the garage, we don't need a window, we need a big door. So if we go to doors, by default we have only this single flash. So for the garage, we have to insert something new. We can go to insert, we can go to load family, and here we have doors. And we have to find a door, something like that, okay? Either this one or this one. This is door overhead sectional. Okay, so let's insert this one and then go to architecture door. And this is the garage door. Yes, something like this. And what else? well, this is up to you. You don't have to design exactly this layout, but every single space, living space, we need a window. I don't know what this is. What the hell is that? If we unhide the picture, and we make it wireframe. Oh, that's the laundry room, and in the laundry we have a small window. Okay, and this is that's the entrance. Okay, yeah, because we didn't have an entrance to the building, and well, basically the garage door is here. Okay, so we need a door here. That's the entrance to the building. And for this laundry, I'm going to place like a small window, architecture window. This 2x10. That. Okay, so I have that small window for the laundry, and that's the door to the house. See it. Apparently, yeah, I have to move those two the doors. I'm going to insert doors again. This door here and there. And why don't I see this? Okay. You see that I can change the direction of the door. If I select the door, I can change here the direction, and then if I move it, I will see the, yeah. Okay, so that's enough. So we need a building with the material, with the right arm values in the material, with triple glazing, low emissivity in the windows, and in all the spaces have natural light. Okay, so we need a window, even if it's a small window, but in all the spaces we need natural light. Okay, so with this we can start placing the spaces. How can we do that? You know that we have to go to Analyze, and we can select space. So if we go to Analyze and select space, I don't want to upload any tag. And we can place spaces automatically. We can do that because it's a very small building. If it's a large building, we have to be careful. But with small buildings, we can place spaces automatically. 12 spaces created. We close. And where are the spaces? Good question. We have the spaces there. They are not visible. And why can it be? Because really does something like that. When it places the space, just with this height, let's go up to the roof. So we have that plane above the space, okay, you don't see the space. So we have to work with sections. So if you go to view and you create a section, let's place a section here, double click, and so again, where is the space? We don't know. This can happen because in the visibility graphics, if we edit and we go to space, these two options are not activated. Okay, so we need color field, interior, and reference. We apply, click OK, and now we do have the space. Okay, so exactly this is what happens. So we have the space, and the space is very low. Why does Revit do this? I don't know. But by default, we have that space. It's on level 0. That's correct. The upper limit is level 0, and we have an offset of 2 feet. Okay, so the height of that space is 2 feet. Well, that's not correct. We can change the limit offset, or we can change the upper limit. If we change the upper limit to 10, this is what we get. Okay, but it's not enough, because in this case we have a tilted roof. So what we have to do is to move this up, and you see that the space adapts the right shape. Okay, but that happens because I'm using a file in which I have set the values to make this happen. By default, it doesn't happen in Revit. If we go to architecture and we look at room area, you see that here we have area and volume computations. That's tricky, and I don't know why that happens in Revit, and it's not by default. By default, we have the areas only. If we click OK, this is what happened. Okay, so this is what you will find by default in Revit. If you don't select the areas and volumes, the space will be something like that. So when you have a flat roof, you can work with this because you only have to check the right height for the space. But when you have a tilted roof and you don't compute the volume, that weird thing happens. And of course, that will give you a complete result because the space is not enclosed. Okay, so space is something that goes beyond the building limit. So every time we open a Revit file and we want to work with spaces, we have to make sure that we use areas and volumes. We click OK, and now it works. It's in architecture, room area, areas and volumes. You have it? This is very important in Revit because if we don't do that, first, if we don't check the section, we might find this, that the space doesn't get up to the roof or the ceiling. If it doesn't get up to the ceiling, we have to move it up to the ceiling. If we have a flat roof, it's easy, but if we have a tilted roof, we have to make sure that we have this area and volume. So now we have to select the space, and then we have to move it up. And this red line, you see that there's a red line, the boundary of the space. So the boundary of the space has to match with the ceiling. Well. Okay. If we go to level 0 now, we kind of see the spaces here. We see the spaces. So now we have to name the space because again, Revit doesn't place a specific name to each space. So we have to select the space here in the floor plan. So if we do that, we can filter and select only the space. And now here we have to change the name. So in this properties windows, where is the, okay, so here we have the name, it's just space. So this is the screen port. And apply. And what is this? This is a bedroom. So we have to select this, filter, space, and change the name. And that would be bedroom 1. Yep. So it's exhausting because it doesn't do it automatically. We can place spaces automatically, but then we have to check every single section and make sure first that the height is correct, that the shape of the space adapts to the ceiling shape. And then we have to change the name, and we will have to change something else, okay? But so far, we can deal with that. Are you following me over there? No?
Looks like and I would change the way it itself.
We have the spaces. I select the space filter and make sure that we have a name. This is bedroom 1. I'm not very good at naming things, so you can say bedroom 1, bedroom 2, bedroom 3, bathroom 1, bathroom 2. Okay. So every time I have a different section, so I have to move this section line, and I go to the section, and the same thing happens to all the spaces. So I have to move them up to the ceiling. Okay, and now I go back to the level, and now I see the space, and I have to name them. I don't know why it doesn't let me select the. So I have to select everything and activate only the space. And now I have to change the name. So that's the living room. And now I have to select this one. This is bathroom 1. And what is that? What's this? What's that? What? I know. I know either. Let me. Oh, that closet. Okay. Okay. So this can be a closet. Closet 1 because there's more than one closet. Okay. So you have to keep going. It's a little tough. This is a small building, so Clark, that's why I wanted to do this with a small building. If doing that with your building, it would be crazy, a nightmare. Okay, so every time we create a space, we have to check in the section that it has the right height, especially when we have a roof that it's not flat. When we have flat roofs, this is easier, but when we have these kind of complicated roofs, we have to make sure that all the sections are like this. Then I have to visualize the space in the floor level. I have to select the space, and I have to change the name. That's because we can have space 1, space 2, space 3. It's in a single family house, I can get by with that. But when the building is too complicated, especially we have a hotel with 100 rooms, we cannot have space 1, space 2. We don't know. So usually we name this first floor, a room, whatever, something like that. So we need a criteria to naming the spaces. And then the most important thing is we have to move the section line, and we have to check that all the spaces have the right, especially the right height. Okay, so every time we find something different, we have to move the section line we have to go to the section and we have to go to drag the space up to the ceiling. And then go to the level. We'll do that again. Section 1. Look at this. I have created this kind of roof. Okay. I don't know. I'm not very happy. I will run a simulation with this, but when we have such a complicated roof in the section, we see the complicated shape that we have here. I don't know. Sometimes Revit is not able to simulate such a complicated roof. So I will have to analyze the results and to see if those results make sense. And if they don't make sense, I will simplify the roof. Okay, so that's why I told you that sometimes we have to model a simplified version of the house, because from the energy point of view, the difference between this roof and a roof that has just 2 slopes, probably the difference is we can't tell the difference when it comes to the energy results, but Revit usually doesn't like, none of the simulation software likes this kind of complicated roofs. Okay, so even professional simulation software tools that you have to pay thousands of dollars per to get the license, you have to end up simplifying the model, and sometimes you have to simplify even the tilted roof. So, and you have to create like a rectangle. So we are making a mistake just by modeling the architecture of the building. So let's see. Here we have a complicated roof shape. In theory, Revit adapts the space to that roof shape, but we have to check the results. Okay. So anyway, we have to check all the rooms with the section. And finally, the garage there. Okay. So I think now we're good, but remember that you have to select the spaces in the floor plan, and you have to change the name, at least the name. But changing the name, it's not enough. Okay, so it's changing the name is just to understand what we are dealing with. But there's something even more important than the name. Okay, so look at this. I'm going to select that space again. This is bedroom number 1. And the most important thing is the yeah, so the space type. Okay, so here we have space type. By default, sometimes in Revit, we have plenum. I think I explained what the plenum is. A plenum is the space that is between the false ceiling and the structural slab. Doesn't make sense. So for the space type, I have to change. What do I have to change? So I would change, do we have a bedroom or something like this? We don't. So I have to change something that that looks like a bedroom. So we have dining area. Okay, dormitory bedroom. Okay. So we can select this one. Okay. But it's not enough. So if we rely on Revit's assumptions, we can select this, we can click OK. So we can select all the bedrooms. Okay, so if I select this bedroom, and keep selecting spaces. Okay, so I have selected all the bedrooms. So we have bedroom 1, 2, and 3. I can go to the space type. So the space type is dorm. Dormitory bedroom. Okay. So now these three spaces would be dormitory bedrooms. Okay. So if I have a bathroom, so I have to select this one, and then I have to change this to the bathroom. But it's not enough. Anyway, especially in single family houses, well, even in commercial buildings, we have spaces in which we live, human beings live or stay for a long time. And we have other spaces in which people usually are not there. So the garage, it's an example of that. So we don't have a heating system in the garage unless we love our cars more than ourselves, but sometimes happens. But we usually don't have a heating system in the garage, okay? So you have to select all the spaces, you have to name them. So the main difference between different spaces is the space type. If it's a dorm, if it's a bedroom, Revit understands that it needs a heating and sometimes a cooling system. But what about the garage? So just select that space, filter. And here, what's the space type? Okay, it's not a plenum, that's for sure. So do we have a garage or? Probably we don't. So first, do not activate this plenum. Okay, so if we don't activate this plenum, here we have the condition type. It's unconditioned, okay, because we don't have a heating and cooling system. So let's select this unconditioned, and that's it. We don't have to do anything else with that space. So Revit understands that it's not outdoors, okay? So there's a boundary, so this is a heated space, and we have a boundary, or we have a, yeah, so there's this line, this wall is separating it from something that is not outdoor, but it's not heated. Okay, so the temperature on this garage, it's not a comfort temperature. If we have 70 Fahrenheit here, we won't have 70 Fahrenheit there. So it's a unconditioned space. So depending on the outdoor temperature, so if the outdoors it's 0 Fahrenheit, maybe the temperature in this garage would be 40, 50 Fahrenheit, depends. But Revit doesn't, well, Revit understands that it's not outdoors, but it's not a heated space. And that's important. If we had a heating system in the garage, fine, you love your car, and you will spend more energy, which is fine, okay? But you need to know what you're doing. If you have a heating system in the garage, perfect. But your energy consumption will be way higher if you heat up your garage. On the other hand, if this is an unconditioned space, when Revit does the analysis, it doesn't, well, this is not an outdoor space, so the temperature of this space is not the outdoor temperature, but we don't have a heating system on that space. Okay, so this is the first thing that we have to understand. The difference between conditioned space and unconditioned space. If we have a heating and cooling system, that's fine. If we don't have a heating and cooling system, we have to select this unconditioned space, and that happens in garage, in mechanical rooms, sometimes the attic, sometimes the basement. It's up to us or up to our clients. Okay, so we have to ask them, okay, do you want heating in your basement? Yes, I do. So that space will be whatever, a bedroom or whatever. Do you have heating system in your attic? Yes, because when my mother-in-law comes to my house, I have her sleep in the attic. Perfect. So place a heating system in the attic. Sometimes no, the attic is just a storage. I don't want the heating system. Okay, That's fine. Both things are fine, but we need to know what we are doing. So that's it. Okay, so what I want today is the spaces and at least the difference between heated spaces and not heated spaces. So the garage is a perfect example of a space that is not heated. We might say the closet. Well, this is so small that I wouldn't change it. Okay, so you can make this closet as a part of the bedroom, or probably it's a part of the bedroom because it's always open to the bedroom. I don't know. Anyway, I need spaces. I need to make sure that in the section all the spaces go from the floor to the ceiling, and I need to know that you have changed the space name and the space category. Okay, so if we select that one, I have to go to space type. Click here. We don't have a plenum. We have the condition space. This is heated and cooled. Okay, and the space type is not just building. Is something that can be bathroom, restroom. We have restroom. Okay, so we can do this. Okay, so select all the restrooms and change the space category. We have changed the bathrooms. All these, the screen porch and the living room, we can select all these spaces here. And the category, we don't want plenum. It's heated and cooled. And the space category is what? Dining area. Do we have living or something like that? Laundry, living, but hotel. Well, I don't know, living, something like that. Okay, so we have a few spaces, not a lot. So imagine that we have to do that with a hotel with 120 rooms and a laundry and the restaurant and the kitchen. So it takes a lot of time, but without doing this, we don't know what we are doing. If you are working with your capstone, I assume that you don't have the spaces yet, and but eventually we will have the spaces. So try to simplify the room. If you're working with a residential building with a retail space in the ground floor, so we will have to kind of spaces. We will have shops or retail or whatever, and then we will have living or bedrooms, the rest of the spaces. Okay, so try to simplify things. And if you have a mechanical room, that will be an unheated space. But we need something like that as soon as possible. Okay, even if it's not the final layout, but from now, if next week you come up with the first layout, a very basic layout, we can start simulating things. And then even if we change the layout, we need an idea of the general energy consumption of the building. So even if you have, oh, I had 30 apartments and now I have 32 because they are a bit smaller. Okay, it doesn't matter because out of the general energy consumption of the building, having more or fewer internal partitions, it doesn't make any difference. Okay, so come up with the layout as soon as possible, and then we will try to simulate it. So today it was about finishing the model. We have windows, roofs, floors. I need to see the spaces, especially the section. I need to see that if you have a complicated roof shape or ceiling shape, the space is adapted to that shape. And what else do we need? Yeah, something about the solar collectors. So now we are going to try to do what we did last Monday on the solar collector front. So we have a nice roof area facing south, okay? And part of this roof area facing south will be covered with PV panels, and we need solar collectors. So this is what we need now. We need to identify the surface that we can have exposed to solar collector, or we can have the part of the roof that is occupied by solar collectors and the part of the roof that is occupied by PV panels. If we have a roof like this, part of this roof facing south and part of this roof facing north, forget about the northern roofs. So we have to use only the south. So let's do it. First, if we are dealing with a house like this, and we are talking about solar collectors, so what did we do last time? Okay, so we need this information. Okay, we have a collector area. We don't know yet. Okay, well, we don't know yet. We have to figure it out. How many people? We had like 20 square feet times the first 2 people. Okay, so how many rooms do we have here? In this case, we have 3 bedrooms. 3 bedrooms. We can consider that we will have 6 people maximum in the house. Okay, so the main bedroom, this is basically the main bedroom. So we have 20 times 2, and then we have 14 times the number of children, or the number of, in this case, is 4. Okay, it depends on the number of bedrooms. Probably if there's a bigger house, here we have bedroom 1, 3, primary bedroom. Okay, so apparently all these houses have 3 bedrooms, but anyway. So if we have 3 bedrooms, the collector area would be 20 times 2 plus 14 times 4. So how much is this? 14 times 4. This is 56 plus 40. It's around 96 square feet. Okay, so we have 6 people, and the solar collector area is 96. Now, each solar collector, remember, we have to open the F chart now. Okay, so let's go to C. We have the F chart demo. So open the F chart software. Let's change the system, because we are we will start with the active domestic hot water. We just need domestic hot water. So the number of solar collectors in this case is, we have the area. Each solar collector has 20 square feet. So 20 times 5 will be 100. If we have, okay, so we can say that we have 5 solar collectors. Let me, I think you do, but let me times 20 square feet. So this is around 100 square feet. Okay, so this is the orientative area depending on the number of people. But now if we have 20 square feet per solar collector. If we can have 5 times 20, it's 100 square feet. It's slightly more than 96. So I started with the estimate solar collector area. This is always square feet, depending on the number of people. If I have 6 people in a single family house, I have 20 times 2 plus 14 times 4. So that gives me 96. Each solar collector is 20 square feet. So if I have 5, I will end up having 100, which is slightly more than 96, but that's fine. Okay, so that's the solar collector area. Is 100 square foot. The storage, I need 2 gallons per collector area. So that would be 2 times 100 square feet. So that will be 200 gallons. Okay, so 200 gallons. Now, the daily hot water usage. We came up with this. So we have like 15.8 or 16 gallons per person and day. So we have 6 people. We can round up 15.8, let's say 16 gallons per person per day times 6. So that would be 16 times 6. It's 96 gallons. Gallons per day. Okay, so that's the first thing we have to do. And then I will start with these numbers, and then if I have to change something, I will do it. But I will start with these numbers. Okay, so open F chart. The first thing, change the location. We are not in the southwest, we're in the northeast. Okay. And then let's go step by step. How many solar collectors? We have 5 solar collectors. So the number of solar collectors, 5. Collector area, it's 20. Okay, so that's fine. We're not going, this is the efficiency, so it's around 0.7. We are working in collectors, we are working with a flat plate. Okay, so we are not working with the evacuated tube. We're working with a flat plate, the cheapest option, the ugliest too. But let's say that we are working with this flat plate collector. So we are not doing this. Then the collector slope, that's interesting. By default, we have 45 degrees. What is the slope in my roof? So if I go to this, the slope is 6/12. So what does it mean? It means if I have a 12-foot horizontal length, the height is 6 feet. So that's the slope. How can we turn this into degrees? Well, I can calculate this using sine and cosine, but there's another way. If we go to manage project units, here the slope, if we click here, we can select degrees. And then we click OK. And I hope that if I select the roof, the slope is 26 degrees, 26.5. Okay. So there's a relationship between the 6/12. Okay, so we can define the slope like this. So we have 6, that means the height divided by the length. But if we want to turn this into degrees, so this is 26 degrees. Okay, so in F chart, we have to introduce this data as degrees. So we go to F chart. So the collector slope is not 45, is 26. The azimuth, it's south. Again, don't place anything that it's not south oriented because the efficiency will drop a lot. Okay, so we are placing this in the south. I don't know if it will be here or there, but it will be in the southern part of the roof. So what else? Collector flow rate area, that's the flow rate, okay? And test collectors, okay. So I think we can keep the rest of the inputs here. So the number of collectors, the slope is the most important thing that we have to change, okay? Now, in this window, we have location, it's northeast, water volume collector area, 2 gallons. It's usually what so we have to be consistent. If we type here 2 gallons, then this has to be 2 gallons, okay? The fuel. I told you that in this case, we're going to use a mix of hot water and electricity. So we're not using gas. Okay, so we can, especially in your capstone, we can think about it. But in this case, in the single family houses, we're going to use electricity and hot water. But the fuel is electricity. The daily hot water usage, we calculated this here. The daily hot water usage is 96 gallons per day. So it's not 80, it's 96. The water set temperature is always 140. We don't have to change that. The environmental temperature, that's important. Where do we place our water heater? I think we have enough space because this is like a laundry room. So I think we can place the water heater in this room. So we can assume that the water heater is gonna be inside the house. If the water heater were in the garage, probably the temperature would be different. But this environmental temperature, if it's 68 or close to 70, that means that the water heater is inside the house, inside the heated space. If it's not inside the heated space, then that temperature would be different. But let's assume that I think in this case, we have that laundry area, and here we have enough space for the water heater. So let's keep this. The UA auxiliary of the storage tank, we can assume that this is, and okay. So we don't have to change a lot of things. We have to change the number of collectors. We have to change the slope. We have to change the daily hot water usage. So with this, we can run the simulation, we can calculate, and this is what we get. Okay, so that's what we get. The F chart, I told you that the yearly F chart should be around 0.7. Yes. It might be different. So with 5 solar collectors, I had like 0.5% of the yearly domestic hot water. I tend to think that 70 is a good number. So with 8 solar collectors, we have 70% of the yearly. And we have in June and July, we cover 100% of the energy we need. I told you that having one, it's great, but if we have one in many months, we might have problems with the overheating. Okay, but that would be an option. So if we go to run plot, and we use the monthly plot, and we select the F value. Okay, so with the F, this is the percentage that we cover month by month. So in summer, I cover 100% of the domestic hot water. In winter, it's around 20, 30. Okay, but we have fewer hours of sun, so that makes sense. But the average is around 70%. So I can plot this, and I can plot the auxiliary energy. That's interesting. Okay, so that's the energy that I need to apply to in summer. I don't need any energy, but in winter, I need this energy to cover the rest of the domestic hot water that I need. So if I just take a screenshot of the F value, and I place it here, and then I can take another screenshot of the auxiliary energy. Okay, so that's what I need. And this is the solar collector, option 1. This is domestic hot water. Okay, there are other options. And I have to change this slightly. Okay, so this is the first approach. But now what I have is smaller. So my number of collectors is 8 times 20. So we have 160 floor area, collector area, sorry. The storage, I have 2 gallons per collector area. So now it's not 100, it's 160. So I have 320 gallons. And the daily hot water usage, well, I haven't changed that because it's 96 gallons per day. Okay, so if I can make this smaller. This is what I get. Okay, so that's a good summary. This is the first approach because I don't know anything yet, so I need to start calculating things with these numbers. But then I find out that this F value, there's something else I have to place here, is this table. Okay, because here I have this is important. Okay, so I should focus on this number. So this number should be close to 0.7. Okay, so that's the yearly percentage of the domestic hot water that I can generate with my system. So it should be closer to 0.7. Okay. So now I need 160 square feet. So now I have to start making decisions on the design front. I have this roof, so I make the most of the slope of this roof, and now I need 160 square feet. So how much is it? 160 square feet on my roof. Okay, I can go to the section, and where is the south? I don't know. Okay, so if this is the south, I have to open the east elevation. Okay, so on the east elevation, this is south. So now I'm going to create a roof by extrusion. And I'm going to start here. And I don't know, usually those solar collectors, it's 3x6 or 3x7, something like that. So I can have like a 6-foot line here. I can click OK. So that's the roof, but I want something way thinner. So we have this 9-inch. Can use this. Okay. And now on the 3D view, imagine that we have this part of the roof with solar collectors. If I click here, what's the area? The area is 282. So this area should be 160. So now it's 156. Yes, so this is 160, kind of. So that's the, because now, do we have enough space in this roof? Well, we have enough space for this, but now the rest of the roof should be covered with PV panels. So we have to start thinking about the design. So here, this is the theory. I need 160 square feet of solar collectors. And how much is that in the actual roof? So, well, this is the roof that I have available. And yeah, we have plenty of space. But if the next input is to calculate the amount of PV panels that I need to make this a zero energy building, will I have enough space with the rest of the roof, or maybe I have to cut down on solar collectors and have more PV panels, or the other way around? I don't know. But so far, this is my outcome. Okay, so I have these numbers. That looks good because this value is almost 70%. So that looks good. But now, what does my building look like? So I can take a screenshot. And I can place it here. Okay, so now this is solar collectors, option 1.